Welcome everyone to this session on writing trigger frameworks in Salesforce. So good morning, good evening, based on whatever time zone you are in. Uh, I think we started after a short break in our set of sessions. So hopefully, the next set of sessions won't really have breaks, and it'll be a continuous flow of sessions. Thank you for joining once again. So. Just a quick information about me. My name is Jigar Shah. I'm an enterprise solutions architect with Adana Solutions. We're a consulting partner, and I'm also a global community speaker. Jigar Shah 189 is my Twitter as well as LinkedIn handle. So you guys, if you feel that you have more questions, you can follow me on this particular handle and feel free to reach out to me. Path to Code is also the Twitter handle for our program here. So you can also post questions tagging that particular handle, right? So what are we going to be talking about today? So we're going to be talking about, why trigger frameworks are needed. Some of you may have heard this term before of what a trigger framework is. Some of you may not have heard that, and we'll kind of dwell further into it as we go through this session. But yeah, we're going to be talking about trigger frameworks. What are the different patterns that you can use to create trigger frameworks? What are the benefits that you see? And I've tried to come up with a ready reckoner which helps you choose what framework is kind of better for you, and hopefully make a choice while select, and helps you select the right kind of framework. Now, one more thing that I'd like to mention over here. If you go out and search on the web, there are tons and tons of different types of frameworks. I may not be able to cover each and every framework here, but at least some of the most obvious ones which you can use in your real-time projects, and hopefully that kind of benefits you, right? At the end, we'll of course have a Q&A session, so you can either hold on to your questions until the end. Some housekeeping rules. Please mute your mic. If you have questions during the session, don't wait till the end. You can post it in the chat window, and we'll try to answer it to the best of our abilities at the end of my session. Please don't shy away from asking questions. We're all here to learn. So any and every question is welcome. And like I said, we'll try to answer it in the last 15 minutes. So we'll just keep a room for that.
Hey, Jigar, I think your screen is paused. We are only able to see the first screen.
Okay. All right. Can you see it now?
Yeah, I can see now.
All right. Perfect. So let me just help set the context here, right? We're not going to be talking about how to write Apex triggers in this particular session. So this session is not about learning to write Apex triggers. The assumption is that you already know what triggers are, and we'll just do a quick brush up on that, right? But the focus on today's session, today's session focuses on how best you can write these triggers, so that when you're really writing out these triggers in a real world environment, what are the typical challenges that you face? How do you write it in a way such that it helps implement best practices, and it's easy for you to write triggers? So, and that's typically where we're going to be focusing on. So, but just to take a step back and give people a refresher of what Apex triggers are. So triggers are nothing but basically that's Apex code that executes in response to database operations, right? So whether you are inserting a record, or you're modifying a record, or you're deleting a record, or you're undeleting a record, you can write triggers on that. And triggers come in basically two flavors. There is a before trigger, and then there's an after trigger. So basically, before a record save happens and after a record save happens. Actually, it's not a save. It's typically a commit that we talk about in database terms, right? So this is typically when triggers execute. And when you write a trigger is basically tied to an S object. Now it could be a standard object, or it could be a custom object, right? Most of the standard objects you definitely can write triggers on. There are some which do not allow writing triggers. There are objects like an opportunity contact role, or the count contact role. Some of those objects, standard objects, do not allow writing triggers. But any and every custom object that you create on your uh, org, assuming that you're having the right kind of edition which allows writing Apex, you will be able to write an Apex trigger for your respective all your respective custom objects, right? So that's just like a quick refresher on what triggers are, what they do, and where are they applicable. Basically, triggers are written when you have some complex logic being performed across records that are not really related, or you want to iterate a lot of records, or you have really custom logic, business logic, or you want to do a series of calculations when a record is saved, or modified or deleted, things like that, right? So that's about Apex triggers. Now, one of the key things when you write any kind of automation on your Salesforce instances is that you got to remember the order of execution, right? And order of execution is the Salesforce defined order in which all your artifacts execute, right? So typically what happens is a record is loaded from the database, or the record in consideration is kind of loaded. Then there are validations which fire. Then so there are that's a combination of system and custom validation rules right here. And then, of course, there are a series of things that happen. But what we're going to be really focusing on in this part is the before triggers and the after triggers, right? Uh, right. Believe me, when you start writing triggers in a real-time environment, it is much more complex than what you think, right? That's because a trigger could also result in a DML operation, which will trigger, or which will in turn invoke a chain of operations, which could result in the execution of any and every artifact that is listed here, provided you have uh, you know uh, automations around those artifacts. So you could have a trigger which could run on an update and check for something, and then update a record on another object, which in turn has a trigger which could fire, and then a series of triggers again fire, and maybe that could trigger a workflow, and then a flow and a process builder, and a ton of other things. So it is very important that you have some kind of mechanism, okay, to orchestrate and control this execution. And especially when you are writing triggers, this really is of great importance. So that's the reason why one of the key things to remember is the order of execution, and to make sure that how your triggers are behaving in the overall uh, context of the provided order of execution on Salesforce. So what really happens, so just before we jump into anything, I'll just like to set the context. For any and every example that we do today, we are going to be using a simple use case. The use case is very simple. So whenever an opportunity is inserted or modified, and the stage is set to closed won, right? We want a task to be created for that opportunity, and the subject must be set to a follow-up test task. So that's the use case that we're going to adhere to for all the examples that we have here, right? Now, that brings us to our first thing of, let's just see how triggers most of the times are written, right? How, before we even jump into writing trigger frameworks, right? Let's understand how typically triggers are written, and what happens when you write your business logic in triggers. So what I'm going to do is I'm going to now switch from my um, presentation to my Salesforce instance. and hopefully everybody should be able to see that. Can someone please confirm if you're able to see my Salesforce instance?
Yes.
All right, perfect. So what I have is a basic trigger written over here, right? The trigger is doing the same thing. The only thing is that the entire business logic or the entire piece of operation that needs to be performed is written within this particular trigger. So let me just walk you through the code and we'll see what are the pitfalls that can arise when you start writing triggers this way. So this is a trigger which is an opportunity, right? And what happens is it's trying to check if it's a before trigger or an after trigger, right? And after event fires typically when a record is committed, and then within that it's checking if what kind of operation it is, if it's coming through an insert or if it's coming through an update. And then it's trying to iterate over the records and check if the stage name for the given records or the modified records is closed one, and then it's adding it into a simple list of type tasks, right? It's setting the subject, the description, and the what ID. What ID is typically, if you want to relate a task to any kind of parent record, you either use a who ID or what ID. Who ID is typically for objects like lead, contact, and users, but what ID is typically for all the other type of records, which could be even your custom records. Now, so that's what it does, and checks if there are any any relevant tasks which are created. It just inserts them. So very simple, right? Looks very clean. Everything is at one place, but there are quite a few problems with it. And let's go back and see what happens. What happens when you start writing triggers this way, right? So so there are quite a few situations that you start encountering when you write triggers that way. One of the first things is, because everybody and anybody is able to write triggers, right? Everybody starts writing their own triggers, right? And Salesforce does not restrict you from writing multiple triggers on a single S object. But the problem is, okay, what will happen is if I had, in this particular case, if I had another developer write a similar trigger on the opportunity object, let's say maybe opportunity trigger 2, okay, there would have been no way of determining which trigger runs first, right? So you basically don't have control, and there is no insight as to which trigger runs first, and which could create problems. It could result in race conditions. It could maybe you have a specific order in which you want your logic to work. So you want an operation to be record to be created first, maybe like insert an account, and then create an opportunity, and then calculate some commissions on that opportunity. Now each of this is sequence dependent if you look at these operations, right? But if you start writing multiple triggers on a single object, there's no way of identifying the sequence. Hence, as a best practice, it is always recommended that you write a single trigger on per S object. So you should only ideally have one trigger per S object. Now, other problems are these kind of code bases which are written are not very maintainable, right? So tomorrow, now let's be real, we all live in a real world, and business logic or businesses mutate and they change their rules on which they operate on change. So today, if I wanted to, let's say, on this particular piece of logic, I wanted to do something else. Maybe on when a closed one happens, I want to calculate a piece of maybe a commission for a sales guy. What I'll have to do is end up modifying this particular code. Okay. Now, one of the basic principles of design is based on a principle called as an open close principle. Now, what does the open close principle mean, right? The principle says that any system that you design or implement should be open for extension but closed for modification. However, when you start writing logic or code this way, you kind of violate that particular principle. So what will happen is tomorrow, if you had to do something else in this particular, which kind of ties in with this particular logic and needs to be done on the opportunity object, you'll have to end up modifying this code, which means, the moment you start modifying code and existing and tested code, which means that you're introducing bugs. So maintainability goes for a toss. Second thing is, if I wanted, let's say, the same logic, let's say tomorrow, if a task is set to a certain, if an account is set to a certain status, or let's say a payment or an invoice is marked as paid, which is where invoice is a custom object, and I want a task to be created for that particular object, even in that case, I want the same logic to be reused. I will not be able to reuse that logic. So code reusability is is zero, right? It's absolutely minimalistic. So these are some of the caveats that kind of endanger or come with this method of writing triggers. So although this suffices the problem, this doesn't really help, because these are some of the caveats that really um, act as blockers and hinder your development or your go live in the real world when you're really working on a enterprise scale or with lots of customizations or lots of modifications, right? And you could also have multiple developers working on the same piece, right? Or maybe same pieces of the same trigger, but different pieces of logic. So there is no way they can use, or they can work disparately without stepping on each other's shoes. So these are some of the challenges that kind of come with writing your triggers this particular old-fashioned way, right? And that's exactly where your trigger frameworks come in, right? So one of the reasons a couple of reasons for having trigger frameworks. One, it helps you orchestrate your trigger logic, right? So what happens is, if you write your business logic in a trigger, there is no consistent way of how it's orchestrated or structured, right? This leads to a lot of complexity and difficulty in maintaining the code, right? So at a given point of time, you want to go and modify the code. It's very difficult to do that, and it's very complex. Troubleshooting becomes difficult because there is no consistent way of executing a trigger. Um, Testing your code becomes very difficult, especially when you start writing your business logic within your trigger code. And last but not the least, like I said, when you have multiple developers who are trying to work together on a single code base, it all becomes difficult. And all these typical problems can be addressed by introducing a trigger framework. So basically, trigger framework is nothing but you're putting a method to the madness, and you're putting some kind of discipline where the logic is structured, things are easy to maintain and modify, and then multiple people can work seamlessly on a single code base. So let's see how we can do this. So one of the first pattern is a very basic pattern, is a trigger handler pattern, right? It's absolutely simple. You have, and this particular diagram here kind of showcases what that pattern is. So you have an S object typically, right? And you will write one trigger per S object, which means that you will have a trigger on that object. And then there is something called as a trigger handler, which acts as a delegator, right? It will delegate the control of your execution to the appropriate business logic, right? So what will happen is, in our case, if we were talking about, let's say we had to create a task, calculate commission, and send out an email, right? And if I could look at that as separate pieces of business logic where there is a specific sequence, your trigger handler is capable of delegating and orchestrating the flow here. Okay. Now let's look at how this is actually written. Right. So the S object trigger here is nothing but the apex trigger. The trigger handler is nothing but a class, and then business logic is small as pieces of, or apex class having pieces of business logic specific to the area that you're trying to operate on. Right. So for example, creating a task could be one piece of business logic in one class, and sending an email could be another piece of business logic. So let's just see this particular trigger handler framework in action. So what I'm going to do is now I'm going to switch back to my Salesforce instance. So this was the initial piece of code that we saw where everything was written in a single trigger. Now let's just break it down. But before I do this, what I'm going to do is typically, so right now I have these triggers written on my opportunity object. Just to showcase or demo these triggers, I'm going to turn off the older one and turn on the new, which also is a problem in the real world. Okay, what happens is when you write triggers or in the real world and you deploy them to production, right, it is not just, so what happens is the triggers start executing, but there are a lot of maintenance operations like, you know, data loads, or so you could have a trigger maybe which is written on sending emails to customers, right, when a record is updated, but you're doing you know, some kind of data load from an older system which is sunsetting and trying to get that data into your Salesforce instance, and you're trying to do a bulk upload, right? Now the problem is, because this is a developer instance, or you know, maybe on a sandbox, you could uncheck this flag directly and you could deactivate a trigger where you want to say that I do not want the trigger to send out emails when I do a bulk upload, and then I can just send them later when my business logic kicks in, when the data load operation is complete. So this flexibility is not really provided uh, in, you know, when you're using the regular triggers pattern where everything is written in a you know, in the regular at one place in a single trigger, right? So I'm just going to, for now, switch this particular trigger off, and just to showcase how we can break down the business logic, right? So we're going to be looking at the same logic. I've broken it down now using the trigger handler pattern. So what does the trigger handler pattern say? I have a trigger, I have a trigger handler, and then I have a business logic which does business specific executions. So I have this opportunity trigger too, which does the same thing now. But what I've really done is, if you compare the trigger code earlier and the trigger code now, it's much cleaner. What I've done is I've moved out that logic, the piece, the business logic in this case is the logic to create the task records in the context of an opportunity. So that entire logic has been moved out. So your trigger becomes less bulky and less messy, right? Uh, and what is happening is this particular trigger is now invoking the handler. So basically what is happening is all you do is write all your standard operations over here and just invoke the handler for every operation. Now, what you have done is, one, you will never have to make any changes to the trigger because you've listed down all the operations. In my trigger right now, I do not have all the operations listed, but you can just list down all the operations. And there is a specific handler method which is written for every trigger event. So if it is an after insert, there is a respective after insert method written. If there is, let's say, an after update, there is an after update method written, right? And what we're typically doing here is passing the trigger instance variables, right? Now, even if you don't pass, these variables are available, but I prefer to pass them explicitly so that they are available, right? Uh, and what I've done is now the same, if you see, there is no logic which really creates the task in this particular method on after insert, neither on an after update, right? The logic has been further broken down into a task service class, which is only responsible for creating tasks, right? All you are doing is now you are just qualifying the opportunities which suit the criteria, right? And uh, just sending those qualified opportunities to the task service list, task service create method in task service, right? So all it does is if it finds relevant opportunity records, it is just going to create it's going to add a task and just insert it into the database. So basically it's creating task records. Now the same thing has been is being done in this particular pattern versus the earlier method. However, in this case, the second case which we are seeing, right, what will happen is the logic is much more reusable, right? So what happens is your task service now or your task creation is broken down completely. So let's say if you had a different requirement, right? Of let's say creating now in this case, because I'm explicitly passing opportunity records and this is in the context of opportunity records, I can do that. However, you can further break this down into something, one method which only creates tasks irrespective of the type, right? So the logic becomes much more reusable, or you could have a requirement of creating these tasks even when something else happens on an opportunity. Maybe a qualification criteria is different. Maybe tomorrow you say that right now you're checking for closed one. You also say that even if it's a closed lost, I want a task to be created so that my sales reps can follow up and really find out what went wrong, right? So all you got to do in that case is just change the qualification criteria over here. The rest of the logic remains the same and it will work seamlessly. So this particular pattern infuses a lot of code reusability, right? Plus there is now a streamlined structure. There is a less bulkified piece of code that is there in the trigger, which means troubleshooting becomes easier, right? Um, the flow is very clean. So you exactly know when you're trying to troubleshoot or when you're trying to introduce a new logic, you can exactly sequence your logic and say that, okay, this is the piece that executes first. And if I want a certain piece to be executing later, maybe I'll call it after this piece of logic and write it down over here. Okay. So that's how the trigger handler pattern typically benefits or helps you address some of the challenges of which come with your uh, regular methodology of writing all their business logic within a single trigger, right? However, this has some caveats, right? It requires a lot of discipline in terms of trying to maintain a single trigger per object. There is still, although the code is now reusable, but it's not completely reusable, right? You still end up writing a lot of qualification code. You still, uh, uh, end up replicating your handler methods. So if you really look at your handler code, right, what happens is the handler piece is repeated for every object, which is a pain because you end up writing more code. And like I said, if multiple people are working on this, everybody needs to be disciplined or needs to follow the same kind of approach, which sometimes is practically not feasible. Right? So that is exactly the reason why we will be looking at our next trigger pattern, right? Uh, so our next trigger pattern is a pattern which typically uses an interface and uses dynamic binding. Okay, and we'll just try to understand what this trigger pattern is. So in this particular trigger pattern, there are quite a few moving parts, right? So there is of course a trigger, because trigger is your sole point of invocation. Then there is something called as a dispatcher. Now your dispatcher is the one which is going to delegate control to the appropriate handler, right? So the handler piece remains the same. However, there is an interface that we will be writing over here. Okay. Now, the interface is for people who are not very conversant. Just try to refer back to your object-oriented concepts. Okay. Interface is nothing but a contract. So it's basically when you define an interface, you're saying that these are the methods that whoever or whichever class implements or implements this particular interface has to provide a definition for these methods. So there is a generic interface. So you're defining the blueprint of your trigger handler, and you are saying that every trigger, every object's trigger handler has to comply with this particular interface. If you do not implement a method with given in the interface, you will flag an error. The compiler will flag an error over here, and you will not be able to save your handler method. So it is an absolute mandate, right? Which means that you are enforcing rules. Okay. Now, there is this dispatcher piece which I will come to, but the dispatcher is really used in orchestration over here, right? And then there is a dynamic binding piece. Now, this particular pattern uses one of the aspects of object-oriented programming, which is inheritance. So what you're typically doing is you are implementing the interface, and by implementing this trigger handler interface, you are inheriting the methods, and you're trying to provide a clear definition to that particular methods, right? And that particular trigger handler can have in pieces of code to invoke specific pieces of business logic. Okay, so I know it could be a little overwhelming at start, but believe me, it's not that complicated. Let's just go and actually see this in action. So what I'm going to do is I'm going to switch over now to my Salesforce instance, and then look at each piece separately, right? So the first thing we talked about was the interface, right? So this is how you typically define an interface. You say public interface, and it's generally a good practice to start all your interfaces with the capital letter I. That's a notation in the programming world, which when anybody looks at it, just by looking at the name, they can tell that this is an interface, right? Now, interface is a special kind of entity because although you define methods, right, but you do not have any implementations for that method. So you don't no method has a body over here. All you're just defining is the signatures, which means what is the parameter type that can be input to these methods, and what is the return type of these methods, right? So what we're trying to do is there are a few methods which kind of correspond to your regular DML operation, but there is something which is also there is also a disabled method, and we'll try to see why and what that is. But this is typically what your trigger handler is, right? Now, the next piece in that particular pattern is so we talked about this interface, right? Now let's look at the concrete implementation of this interface, right? So that's what you refer to a class which implements an interface and provides a body to the methods defined in the interface. So I'm going to switch back again to my Salesforce instance, and then I'm going to look at opportunity trigger handler. This is the handler, which is a concrete implementation of the iTrigger handler interface, right? And now if you see in this particular class, you will have methods for all the methods that were defined in the interface. So each of these methods will now have a body. Okay. And what I have really done, so for now, let's just ignore what is written over here, but they just have a body which has some logic that can be executed, right? Now, the other piece to the puzzle, and the most crucial piece is the dispatcher class. So let's just look at the trigger dispatcher class. Okay. So the trigger dispatcher is a special type of class which has only a single method, right? It has the run method, which is static in nature. The reason for having a static keyword basically means that you don't really need to use the new keyword to create an instance of the trigger dispatcher. You can directly call this method via the class name, right? But one of the things that you see over here is the input parameter to this particular run method is the interface that we had defined, and that is the iTriggerHandler interface, which means that the run method can take any parameter which belongs to I of type iTriggerHandler. Okay, right? Now, and then it has the common pieces of handler logic, which in the earlier pattern you would kind of replicate for each particular uh, object, right? So if you had opportunity trigger, then you would have an opportunity trigger handler. Similarly, if you had an account trigger, you would have an account trigger handler, right? In this case, you don't really need to do that because this is the common handler piece to that particular problem. Okay. So all this piece is doing is it is checking for the trigger context variables, and then it is delegating the control to the respective handler method, right? Now let's look at what this respective handler method is. So the respective handler method, like I said, is an implementation, a concrete implementation of your iTrigger handler, which means that, so we are, one of the key concepts to understand in this particular pattern is we are using dynamic binding, which means any place where we define that we are saying that this particular method can accept a type or accept an instance of iTrigger handler, can also accept a type of the respective S object trigger handler, because that kind of implements or is derived from the iTrigger handler, right? So at runtime, so when you define the method, you are saying iTrigger handler, but at runtime you could actually pass an instance of the opportunity trigger handler, which is what we will be doing, and you'll see this all in action. So now what really happens is, when you have a trigger dispatcher and when you have an opportunity trigger in this case, first of all, if you look at your opportunity trigger code in this particular case, it has reduced to only one line. So the code is absolutely clean. Like this is, it's really easy to look at a trigger and say, okay, this is the only place where the code is executing from. But if you see now, instead of an iTrigger handler, I'm really passing an instance of an opportunity trigger handler, which is the derived type of the iTrigger handler. So now, irrespective of whether you're writing a trigger on account, you could replicate the same thing, right? And instead of repeating the complete code which you were doing in the earlier pattern, you can now just replace it with a simple derivation of this iTrigger handler interface, and you could say maybe new account trigger handler. You don't really need to repeat that code. So you've kind of reduced your code and you made your code more reusable, right? So what will happen? So let's just see how this all is behaving in action. Okay. Now let me just switch back and turn off the older trigger, and maybe let's just activate this new trigger. So I'm going to turn off this trigger for now. right? So we have our actual trigger which is turned on, and now let's see how this is all firing. So what I'm going to do, or what is our logic? Our logic is very simple. I go to, let's say, opportunities, and I have a few opportunities that are created, right? All I'm going to do is, let's say, look at this particular opportunity with G point lab generators. I'm going to go to this particular opportunity and try to mark this as closed one. So what should really happen is, if our code works fine, there should be a task which should get created. So if you really see, there was no task earlier, but after we marked a specific opportunity as closed one, a trigger executed, and there's a task now created. But what is important is trying to understand, and we're trying to decipher over here as to how this particular task has been created by navigating over to the framework that we have here. Okay, so let's just go back and see how it has executed. So I'm going to switch back to my Salesforce instance. Hopefully everybody can see my developer console. Okay, so I'm going to just open up the log for the most recent execution, and let's see how. So now if you see, what I've done is I've just simply put debug system.debug statements just to give us understanding of how this entire process framework works here. So there is opportunity trigger 3, right? So this is the first piece, and this is what is executing, right? The moment this an opportunity is marked as closed one. Now once that is done, it calls the run method of the dispatcher, right? And what it is doing over here is calling the run method, and it's routing the control to the trigger handler method, right? Now within trigger handler, it's trying to uh, within the trigger handler, it's basically, I'm sorry, it first calls the dispatcher, right? So the trigger internally calls the dispatcher. The dispatcher decides what the context is. In our case, it was an after update, right? So it identified after update, and it just routed the control back to opportunity trigger handler in the after update method. Now, right? And we can see that in the log over here, that it kind of ran, and then it changed the control to the after update method. And then the last thing that happened was the handler routed this over to the task creation logic, which we already have written over here. So did you see that we could now reuse that same logic in this particular trigger also, which means that is the code reusability has increased to a great extent, and you can easily, one is the routing logic has reduced, right? Second is it is more dynamic and flexible, and last but not the least, your business logic is become a lot more reusable now, and that is how the task is getting created. So it finally calls the create method of the task service, and that's how typically a task is getting created in this particular context. So this is one very useful pattern which you guys can use. I know it'll take some time for you guys to wrap your head around this particular pattern, but believe me, it's a really good way of writing triggers, and this has a lot of benefits if you really look at it in the real world. Now there's one other thing I promised, which was not there in our earlier code pieces, was for every trigger you kind of had to go to this particular screen, right? Sorry, this particular screen over here. And if you wanted to, let's say, deactivate a trigger, you had to go to this particular screen, check, uncheck the flag, uncheck this particular, just wait while it loads, uncheck this particular flag right over here. Now, like I said, you can do all this on sandboxes and developer instances, but typically on a production environment, such kind of changes are not possible. So what is a cleaner way to turn off your triggers? Or let's say your trigger is throwing some error, which is not allowing your business teams to enter some data. How do you, and they've requested that you turn off the trigger so that you can at least allow them to enter some data in the meanwhile while you troubleshoot this particular issue. With the earlier patterns, you never had any way to turn off your triggers, right? But in a cleaner way. But with the interface based pattern, you do have a way now, because now within the trigger handler, which is an implementation of your iTrigger handler, you have this is disabled method, right? Right now here, I'm just making a direct change in code. Ideally, if you had to implement this in a much more cleaner way, what you could do is you could just fetch this value from maybe a custom setting or a custom metadata type, where you could just say that give me the value of that particular flag. So now even your admin or any business user doesn't really need to make changes in code the way I'm doing now. You could just fetch that value from a trigger, from a custom setting or a custom metadata type, and that value will, checking or unchecking the flag there, will automatically activate and deactivate your triggers, which gives business users finer control to turn on and turn off your triggers on production instances, which is a huge help in real world uh, implementations. Okay, so let's just try to verify if the trigger works now. Ideally, it shouldn't. Let me just make sure that this is saved. Okay, so this is saved now. So now we have set the flag as disabled. What we are going to do is we're going to repeat the same thing one more time, hopefully with a different um, opportunity now. So this doesn't have any tasks, and hopefully now, because we've turned off the trigger, this should not create any tasks. Okay. I'm still marking this as closed one. Let's just go and see. So if you see now, there is no task that is being created, and I have deactivated my trigger without even having to go and actually deactivating it from the Salesforce side. So let's see what has happened behind the scenes, right? So let's just open up a log. So now if you see, the trigger runs, it makes a call to the dispatcher method, right? But the dispatcher, because it is, there is a piece of logic already in place saying that if it is disabled, just do nothing, just return the control. It's it's not really executing the remaining piece of the logic. So without doing much, you can actually go back and deactivate your trigger, and you can switch it back on by just setting the flag here. So you basically have finer control on activating and deactivating your triggers. Okay, the only thing is I am just simulating this change over here in code. Typically you would not do that. You would fetch this particular value from a custom setting or a custom data type, or maybe a custom label. I mean, there could be n ways to do it, right? But that's how you would do it, giving your users finer control on turning on and off your the triggers on and off purely through point and click rather than making changes in code, right? So yeah, with that kind of brings me to the end of the interface-based trigger framework, right? So there are some clear benefits of the trigger framework, right? One one of the key things here is it provides a consistent way of writing and executing triggers, especially in the interface based trigger pattern. We saw that, you know, the entire overhead of writing the trigger handler logic was removed for every new trigger that you're trying to write. There's a consistent way. Second, because now there is only one way of executing that particular logic. It's more predictable, which means that if you have multiple pieces of logic, you can order it, and they will, you know, hopefully you can predict and have better control. Second thing, just like we added a flag for triggers being disabled, we can also add methods and flags for making the trigger or turning off the trigger when you know, when a recursion happens. So what is a recursion? Like I said, when pieces of logic execute in a Salesforce instance, they will go out, execute, and in turn result in DML operations, which in turn cause the same trigger to execute again, right? If it's not written properly. So you will need switches to turn on and off the trigger in such cases. And that's where such kind of patterns come in handy. The other benefit that is there with this particular pattern is the code pieces are much more maintainable because now they are broken down, right? And it's also easy to test because now you have moved your business logic outside your trigger and you have separate classes that you're trying to test, right? And with all this, your you know, all disparate teams can work better without having to step on each other's shoes in a single code base more effectively, and you know, it's a win-win for everyone. So these are some of the key benefits that you know, trigger frameworks bring to your development lifecycle. Um, just a quick reckoner for being able to choose. Now, this is a question that I often get to hear. Do I always need to implement a trigger framework? Answer to that question is no, it's not mandatory. Of course, it will be good if you implement that because there are certain benefits which we just talked about. However, you know, this table over here helps you kind of see which is a better trigger framework for me based on either my knowledge or the complexity of the implementation that I'm trying to do. So one of the things is the trigger handler pattern that we saw earlier is very easy to learn. I mean, there's nothing, it's an extremely simple pattern as compared to the interface based thing where you have to have a good understanding of how inheritance or object oriented programming concepts are. In the ability to enforce one trigger per object is way higher in an interface-based pattern than as compared to a trigger handler pattern, right? The interface-based pattern is extensible because now a lot of your handler piece, which you would have to keep repeating in the trigger handler pattern, is not required. Of course, because it is extensible, there's a lot of code reusability that comes with this particular pattern. And last but not the least, there's no recursion control or no ability to deactivate triggers directly within your trigger handler pattern, though you could do that, right? But it comes in more naturally and in a much more cleaner and a consistent manner when you're doing interface-based trigger frameworks. So with that being said, that brings me to the end of my session. There are some great resources, some great blogs from some of the community members. There's a blog by Salesforce on writing bulkified triggers. And there's a great YouTube video which was uh, you know, by Adam, who presented on Apex Hours, which is run by me and Amit, our very own Amit Chaudhary. So these are some of great resources. You may see that some of these patterns may slightly differ in the way that I have explained it, but more or less they kind of try to implement or um, kind of state the similar thing, is how you can increase code reusability and maintainability and reduce the overheads which come when you start writing business logic directly in triggers. And beyond this, if you want to get your hands dirty, of course, there's a Trailhead module on Apex triggers. Um, the module itself doesn't really talk about any pattern except for writing bulk safe triggers, but you can try rewriting the same trigger in the pattern that we saw today, and hopefully that kind of gives you a better understanding of how this all works. And last but okay, that brings us to question and answer time. And what I'm going to do is quickly pause my screen share, and I'm going to look at the chat window and see if you have questions over here. So there is a question from Isabella which says, how could I go about in terms of implementing this framework in a busy and complex org? Great question, Isabella. Now, the answer to your question, when you say a busy and complex org, means the org is matured, which means that there could be already existing pieces of trigger that are there, right? So there are two things or two methods or two aspects to implementing this in implementing these patterns to that kind of orgs. One is you got to reduce technical debt, right? Which means that older code that was written which does not comply with this pattern has to be brought into this pattern, right? And second is you enforce a particular you enforce the framework saying that after you bring in or after you've made changes to your existing code base to comply with the framework, any new code that is written has to comply and has to be in line with that framework, with the new framework that is introduced, or else it kind of does not go into production. So typically what happens is when you build something, or when developers develop something, uh, the there's a process called as code review, right, which talks about the health of the code in considering different aspects, things like performance of the code, or how long, how many lines of code, and there are a lot of other things of best practices like whether writing sockles, selective sockle queries and things like that. So in that case, you can also enforce saying that if you're not following a particular pattern that we have enforced, it needs to be changed to ensure that it complies with that particular pattern. Okay, hopefully that answers your question, Isabella. So I don't see any other questions. Do you have any other questions? Feel free to unmute your mic and ask me questions. Any questions?
I think I saw Adam's presentation, and I think he had mentioned not only using interfaces, but another way that used class inheritance or abstract classes. I guess you chose interfaces to show us. Can you tell us why you picked that over the the inheritance, I guess extending virtual classes way of doing it? Why do you recommend the inheritance way of doing it?
Sure. See, the thing is, when you kind of, like I said, first of all, there are different types of interfaces, and nothing is right and nothing's wrong. I mean, nothing's wrong here. One is the convenience that you have implementing one way versus the other, or a comfort that you have with a certain pattern. So the reason why I kind of prefer the interface pattern is because it enforces a mandate. Like I said, when you define an interface is basically a contract, right? So it kind of mandates your developers to ensure that you comply with that contract, okay, with an interface. If you do not implement a certain method, it will kind of error you out and will not allow you to create this particular handler class that you're trying to create in this particular handler pattern that we saw just now, okay, versus in an when an class-based method or an virtual class method, it is overriding that you're doing. So probably um, the 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 checks are not that stringent is what I feel, right? Eventually that also is a type of inheritance which is used, but this is more stringent in nature, and that's the reason why I prefer this. The other reason is I have a comfort using this particular framework pattern, and that's the reason why I kind of recommend it. So there are two basic things. One is your comfort with the pattern. Second is how stringent is that pattern. With interfaces, you can't really bypass it unless you modify the definition of an interface, which means that any and everything that kind of depended on that interface now will also have to change. So it's typically how you look at it. So hopefully there's no that may not be a clear answer to your question, but the only reason why I kind of recommend this is because of the stringent nature of interfaces, and because I am kind of comfortable using this particular pattern.
So to Jigar, to explain a little bit more, right?
Yeah.
So we have a recording in the session, which is episode 3. In episode 3, we have explained when to use interfaces, when to use abstract classes, and when to use inheritance. So if you go by episode 3, I think a lot of things would make clear. So in my opinion, right, when we talk about the trigger framework, the only thing we are talking about is make sure that your trigger, you don't have more than one trigger on your custom object. You don't write logic directly in your trigger. That's number 2. Number 3, have a capability to enable or disable the trigger functionality on the basis of custom setting or custom metadata. And number 4, make sure if trigger is executing multiple times, you have kind of the static variable to avoid the recursive execution of your code. So if you are following this 4 pattern, or you're solving this 4 problem, you can go with any pattern. You can go with interface, you can go with abstract class based as well. That all will work. But fundamentally, this is the 4 problem we are trying to solve.
Was that Claudia, or was it Isabella? And does that answer your question?
It was Adrian.
Okay.
Yeah, kind of. I remember he discussed each approach and the pluses and minuses of each one. So
Right.
I guess I wondered why you in particular, why you favored this approach. And I think he kind of went quickly through each one, so I feel like I have a better understanding of the interface framework thanks to this. So thank you.
Yeah, and one more point, right? So normally we talk about, right, always write one trigger on one object, right? But I have seen some technical architects and even some managed package, for example, field service lightning managed package, they have written 4 trigger on the same object, but all 4 trigger is for the different event. So one trigger is only for before insert, one trigger is only for after insert. So even if you're following that pattern, that will work. Just make sure, right, that you're not having a multiple classes on the same object on the same event.
Right. Yeah, in fact, that's a good, that could be another way of how you, it's all a matter of perspective of how you slice your triggers and compartmentalize them so that there is a clear orchestration, and you, at the time of execution, you can easily say that, okay, this is the route that it is going to take. It has to be more predictable and controlled. That's what it is. So any other questions? I think there's a question from Claudia. Possible to have access to last 19 episodes? Yes, you can. We have our YouTube channel, which is called Path to Code, and all our episodes including today's episode, are there on that. So today's episode will of course be put on that channel later, but all the previous episodes exist there, so you can watch it at your own free will at any point in time.
Yeah, and also you can have access to slides. If you directly go to path2code.com, you will see a list of all episodes, and if you dig into those episodes, you will see slide and you will see directly videos there.
Okay. I do see questions in the chat.
Mm-hmm.
Are you answering those questions?
Yeah. So I think there's one question from Joby which says, is there an exception to one trigger per object best practice? Like we said earlier, right? I think Jitendra just mentioned that is it ideally the best practice. So first thing, Salesforce doesn't restrict you from writing multiple triggers in an object, but that is a problem. And that's the reason why we say that there should be one trigger per object. But there are patterns, right? It depends on how you slice and dice your triggers. So you could also have 4 triggers per object, like Jitendra mentioned a while ago. And that's purely because you are orchestrating it that way. As long as you can comply with the norms and have a predictable execution type, doesn't matter if you have 1 trigger or 4 triggers. But it can't be ever growing, and you can't keep writing triggers on the same object on the same event, because then your order of execution goes for a toss. So ideally, my recommendation is try to only always keep 1 trigger per object. Whatever logic you want to change or whatever orchestration logic that you want to have, try to put it in your classes or your handlers or your dispatchers. That way it becomes much easier. So that's my recommendation. Okay. So I answered a question from Isabella, from Joby. Anybody else? So Jitendra just posted a link to the YouTube channel. So everybody who's right now looking at the chat window, you should be able to have access to our Path to Code YouTube channel. Okay. I hope I have answered all of the questions. I think we've exceeded our time. But even beyond this, even if you have more questions, feel free to reach out to us on our blog, and we'll hopefully try to address your queries and answer your questions. So thank you so much for being a patient and a wonderful audience, and keep joining us to learn more all about development. So thank you.
Thanks everyone. See you. Just a note, next week we are having an advanced sessions on design pattern. Those are the sessions which are very rare, and we are going to cover a lot of design patterns in the next 3 sessions. So please join and please inform everybody. Socialize in your channel, and see you next week. Thanks everyone.
Thank you. Bye-bye.
Bye.
Thank you.